Just kidding here. All right, did you get the right C? That's my first question. Because that's probably why you're messed up if you didn't. All right, so you got leg, hypotenuse, right? So 4 squared plus 4 squared equals C squared. Hypotenuse is always across from the 90-degree angle. A and B don't matter. C has to be across from the 90-degree angle. So if you're looking there, that's got to be C. That's got to be C. That's got to be C. Depends on what your theta is. So depending on theta, let me, this is C squared. So square root of 32 is C. And then you break down 16 times 2. So you don't know how to break it down like this? Okay, so what I'm doing is I'm looking for the biggest perfect square. Perfect squares being 4, 9, 16, 25, 36, and so on. I'm looking for the biggest one of those numbers that I can divide that by. Okay, in this case, it's 16. 16 times 2 is 32, right? And we do that because the square root of 16 is 4, and then we leave the 2 under the radical. 4 over 4 root 2. So you can't have a radical in the bottom, right? That's just the wall. So then you multiply the top and the bottom by the square root of 2, right? This gives me 4 times the square root of 2. Well, what's the square root of 2 times the square root of 2? 2. 4 times 2, which is 8, and 4 divided by 8. What? When did I learn how to do that? I've always known how to do that. Oh, like Alex taught me. She told you she had a question for me? Why are you just not telling me? What did you need, Kenzie? Okay, so the secant. Okay, did everybody get the missing leg here? Square root of 5. Okay. Okay, that's secant. So let's say it right. Secant. Okay. So everybody understands the sine, the cosine, and the tangent? No? All right, so somebody asked how you know which one's adjacent, which one's opposite. So it's based on your theta. So notice they labeled theta here, right? So if that's my theta, my hypotenuse is always the hypotenuse. That never changes. Doesn't matter where theta is, hypotenuse is going to be hypotenuse. But the side that touches it does not be hypotenuse is your adjacent. So that means this is going to be my adjacent. And then completely opposite, it never touches. So this would be my opposite side. So sine, that's my opposite over hypotenuse, right? So that's square root of 5 over square root of 30. Okay, so sine, opposite is square root of 5. And then hypotenuse is square root of 30. Okay? Okay, so this is the same thing as the square root of 5 over 30, which is 1/6, right? So this is 1 over the square root of 6. The square root of 1 is 1. Square root of 6 doesn't have a square root. Now is where I have to rationalize. So I end up at square root of 6. Because you can't have a radical in the bottom. Of course it is. Square root of 30 over 6. This one, the cosine. So cosine is adjacent, so the adjacent is 5 over hypotenuse, which is square root of 30. All right, so now again with the rationalize, I need to multiply top and bottom by root 30. And so I get 5 square root of 30 over 30. And what's outside of the radicals, or what's not under a radical, I can simplify that. So 5 divided by 30 simplifies to 1 over 6. So I got square root of 30 over 6. I know, and I wouldn't be spending as much time on them, but I know you're going to need this. Like, y'all really, I keep telling y'all, but y'all really need to sign up for SAT or ACT after we get through most of it in class. Because there's a lot of stuff with this kind of thing on. It'll definitely up your score. Well, everybody that had it first semester, but y'all didn't. Calculus, we don't graph as much in calculus. I mean, we analyze graphs in calculus, but more like, no, not like, it's not like what you're thinking. Play. Calculus is so different. It's fun.
How come you're not
Huh? Oh, for sure. This is the stuff you need to do the calculus problem. Like, you need to be able to do this to do the calculus, but the calculus itself is not. Like a volume of revolution? Is that what you're talking about? Yes, that's good. That's the very last thing we do, though. That's the very end. That's whenever it takes everything into account. Believe it or not, everybody does really well on that part. But that's the thing. Yeah. Again, did you get the missing side here for 6? No. I can't tell what they gave and what they. Okay. 61. So there's no radicals here, so it should be pretty straightforward for you. So sine, you just have to remember, this SOHCAHTOA. So the sine of theta, this is number 6, by the way, would be opposite. Now remember, if this is my theta, then my opposite is 60, right? So 60 over, some old hag cracked off her teeth on apples. That's the, and if you can remember this,
I do not partners with options.
some old hag cracked off her teeth on apples. Y'all are good at word games. You need another one to remember. We could have one for our class.
Sign off the hip.
Stop.
Stop on highway.
Stopping on.
Stopping on hip. To obtain award. There it is. That's what we do.
Stomping on hippies crazily and happily to attain award. That's great. That's great.
No. If you come up with a good enough one that hasn't ever been come up with before, I might give you some bonus points. What? That's not a good one. No. I literally just said some. No, not one that I can Google or something now. All right. Let's switch gears here. This is still using trig, yes. Anytime you have right triangles, it's trig. No, the back is, I don't really like the back of this. I don't really like what they, was it on the right? I don't feel like it was. Maybe it was. Yeah, no. Yeah, no. Okay. All right, solving right triangles. Yay, day is hot here. Animals are good. Okay. Here's what solving right triangles means. There's no spoons though. What are y'all gonna do?
It should be behind it.
Logan can run down to the cafeteria and get some. Text one of us, yeah. All right, solving right triangles. Here's what we do when we solve right triangles. We find all missing sides. Actually, let me start with all missing angles. How many degrees does a triangle have? And all missing sides. In other words, we find everything. For this, we could use Pythagorean theorem or trig function. We could also use trig to find the angles, and I'm going to show you how we do that today, and that's going to be the new stuff here. No, you just need to know how to do it. Once I show you how to do it, you'll do it. Oh. But you do have to remember SOHCAHTOA. Don't start that. That.
Why not? You just said a curse word, but we can really.
I did not say a curse word. Stop saying that, Dozier. I did not. I do not use that kind of language.
I just heard it.
Okay. I can't even think. Y'all got that? I'm even angry. Sorry. Solve the triangle. That's all it's going to say. Solve the triangle. Pythagorean theorem or trig. Now, oh, okay. What we got. The first thing I do is pick up whatever's the easiest for me to find. In other words, if I've got two of the angles and I'm missing one angle, that last angle is really easy to find. Or if I've got two sides and I'm missing a side, that one side's really easy to find. So that's where I always start. So starting here, I would say this angle is the easiest to find. Do you agree? All right, so what's that 15 degrees? How did you know that? Because he's a genius.
That's right. Okay.
These two have to add to 90 because there's 180 degrees altogether. You've used 90 as your right angle there, so you still have 90 left to give. So 90 minus 75 is 15. Now, we're going to use trig to find one of the missing sides. So what I always do, I always tell students, always go from what you were given. Because you could have made a calculation error as you found this angle, right? So as long as I go back to what was given, it leaves me less room for mess up. So if I let 75 be my theta, okay? So that's the angle I'm going from. What side do I have? Because that's what was given. Okay? All right, so I've got the adjacent. Now, I do not have the hypotenuse and I do not have the opposite. So I can use either of the two trig functions that involve adjacent. So which are the two that involve adjacent? Okay, so cosine. Cosine, remember, is adjacent over hypotenuse, and tangent is opposite over adjacent. Pick either one that you want, it doesn't matter. Logan says let's use tangent. So tangent of 75 is equal to opposite over adjacent. Yes or no? All right. Make sure, everybody take just a second, and on your calculator, hit the button that says mode. And make sure degrees is highlighted and not radian. And do it. And leave it. Yeah, second click. All right. Now, yeah. Because it touches it, but it's not the hypotenuse. Opposite never touches, adjacent always touches. All right. So now I need to solve this for opposite, right? So I'm going to probably come in at this point and just multiply both sides by 21. And you can do this all in one go in your calculator. So just type 21 tan 75 as long as you're in degree. And that should give you approximately what that opposite side is. 78, take it 3 places. 78 point what? That is this side right over here. Because that was opposite. Remember, it's based on where you put your theta, wherever you called theta. I called theta 75. So everything I'm doing is based off of the 75 degree theta. Huh? That's what I said, this is really good stuff for a standardized test. No. He was just saying he missed these. I said take it again.
I'll go aces.
All right, have I solved? Yeah. So literally 21 tan 75. Are you in degrees? Actually, you don't have to use. You only have to use a trig function one time. Past there. Yep. Do Pythagorean theorem to find that last side. So do 21 squared plus all of that squared. Yes. C is always hypotenuse. Has to be. Go through and solve that and find it. See what you get. What you got, Ted? 6,000. Now square root it. Yep. 81.137. $81.138. Good number.
I did it.
Your hypotenuse. But it doesn't matter because you only have to use the trig function for one thing. And then everything else can either be the sum of the angles is 180 or Pythagorean theorem. This is hypotenuse. If this is my theta, hypotenuse, adjacent, opposite. Yes. All right, guys, listen. I need to keep your attention. All right. You think you got it? Okay. What if, what was I missing?
Not possible.
What if we just like wrote notes?
Solve the right triangle. Solve the right triangle. I thought it was a hymn.
45 degrees.
Negative. Oh my gosh, except for no, it's not. Okay, Logan says Pythagorean theorem, and I do agree with him on this, that would be my first step is Pythagorean theorem, find that missing side. Okay, so 18 squared plus something squared equals 23 squared. How did I know that the 23 squared needed to be what it equaled? That's the hypotenuse, that's my C, that's what they have to sum to. All right, so somebody solve that for B and tell me what you get. Do 23 squared minus 18 squared and then take square root. 14.318. If you do this and one of your legs comes out bigger than the hypotenuse, you did something wrong. All right, so we're all in agreement that's easy, but my triangle's not solved because I told you solving means all sides, all angles. Bless you. What shall I do? For what? How? I know 90. Okay, so Logan's saying do 18 over 23. What are you doing with 18 over 23? Okay, so you're calling this theta. Okay. He's just pick one. It doesn't matter. Pick one. I'm going to tell you pick whichever one you want, but I'm with him. Use the sides that you're given. Because again, if I made a mistake in my calculation here, it's going to make the rest of my wrong. So okay, so if we're doing this by, okay, so you're saying we're doing cosine. So you're telling me that the cosine of theta equals 18 over 23. Agreed or disagreed? Everybody see me? See what's going on? Okay, so if you're not given any angles, pick a theta. It doesn't matter where you put your theta, but put it somewhere, right? We put it here at the bottom. If that's my theta, then the sides given to me are adjacent and hypotenuse. There is only one trig function that uses adjacent and hypotenuse, and that is cosine. So I'm going to say that cosine theta equals 18 over 23. Is everybody with me? Yes, David. What would that change? How would that change? If I put the theta here, now I've got opposite and hypotenuse, so I would use sine and say that it's 18 over 23. How's it what? That's going to be the hypotenuse no matter what, because across from the 90-degree angle is always the hypotenuse. It's always opposite. Now, that still doesn't answer my question, though. I still don't have all my angles. I have all my sides, but I still don't have all my angles. How is that helping me? Y'all probably don't know this. I'm setting you up. How do I solve this for theta? We are going to put it in our calculator, but what we're going to do, we're going to do the inverse cosine because we're going to think inverse cancel things out, right? That's what inverses are, opposites, right? And they kind of cancel out. I haven't done anything yet. And this is not, don't ever show this to a math teacher because that's not what I'm fixing. But that's not mathematically correct, but it helps you understand what's going on. So if I do it to that side, I have to come over here and do it to this side. So no, but I want to show you why. A cosine and inverse cosine are kind of canceling each other out. So what this tells me is that theta is going to be the inverse cosine of 18 over 23. So whereas trig functions give me side length, right? Inverse trig functions give me angle. So now if you take out your calculator and you do second cosine, because that's above cosine, it says inverse cosine. So if you do second cosine, this is where some of y'all said yesterday whenever we were talking about the reciprocal things, was that the same as to the -1? I told you no. This is why it's not exactly the same. So second cosine 18 divided by 23, and what do you get? 38 point, give me 3 places. Oh, okay. So 38.5 degrees, right? Because I picked my theta. I picked the theta I wanted. Now, Davis wanted, was that Davis or was that Kev? Somebody said, what if the theta's up top, right? Davis, okay. So Davis, solve your equation for your theta up there and let's see what happens. So, in other words, here, if I do the inverse sine of 18 over 23. Now, I wouldn't have to do this both times because at this point I could subtract from 90, right? And I know what's left. Well, then you don't have to do the 90 also. What do you get, though? What do you get when you do this? 51.5. So either way you do it. So it doesn't matter where you make your theta, as long as you're looking at the sides that relate to that theta that way. Does that make sense? That's it.